Welcome to the video lecture series on syntax directed translation connected with declarations. So, declarations is a very prominent topic which is having close nexus with the principles of compiler design subject. So, we'll be learning about the way of using declarations and the associated syntax directed translation rules, and how declarations are getting updated in the symbol table, and all these things we will be learning in an elaborate fashion uh, in close nexus with the subject. So this is Dr.K.N.Sivabalan. And what is meant by declarations? In general, a declarations is used to enter the identifiers in the symbol table. That means identifiers has to be kept track uh, inside the symbol table for the whole program. And any additional information connected with this identifiers has to be stored in the symbol table. The additional information in the sense is called as data types, this memory locations, if it has any pointer associated with that, all these things are called as additional informations. And there is a procedure or function which is called as enter, which make entries in the respective symbol table of the identifier. And offset is called as a memory location for the corresponding identifier. Now this is called as the grammatical rules or productions associated with the declarations. On the right side we have a semantic rule. So initially when we have P tends to D, so D is called as declaration. Now this declaration is initially having a memory location called as 0, so that's why it has been mentioned as offset 0. Now you don't have only one declaration, in a program you will have multiple declarations, so that's why D tends to D semicolon D. So this production actually facilitates multiple declarations. Now what is this declaration? So this declaration you can have an identifier colon followed by the data type. So T is called as data type. So if this is the type or if this is the production, then we have to enter the name of an identifier in the symbol table. So here enter the name of the identifier in the symbol table along with its type and its memory location. So offset is called as memory location. Now the offset has to be incremented to store the next identifier. So for that you have to take the width of this data type. So offset will be updated with the help of offset plus width of the current data type. Now, and what is this data type here? T is called as integer. If T is an integer data type, type should be mentioned as integer, then the width of integer is 4. That means 4 bytes. Now, when T is data type is real, then T dot type should be real and the width should be of 8 bytes. If data type is an array, so array of num of T1. Now, of T1 is called as a data type here. Now, we'll go back. Now, T dot type, you should make an entry in the symbol table. T dot type is equal to array of number dot val. So, say for example, if number is 10, so 10 should be entered and the corresponding T1 dot type has to be entered here. So, T1 is called as the data type of the corresponding array. For example, this T1 might be integer or it might be real or it might be a pointer data type, anything like that. Now, the last one is T tends to a pointer data type. T tends to, when I use a cap symbol here, it is called as a pointer data type. Now, if it is a pointer data type, it has to be entered inside the symbol table as T dot type, pointer of T1 dot type. T1 dot type can be anything. It can be integer, real, or array, anything like that. Now, T dot type is equal to T dot width is equal to 4. Now, this is how actually the productions rules and the associated semantic rules are mentioned here. Now, we will have an illustration of this, how the semantic rules are swung into action when a corresponding sequence of declarations has been made. So, in this case, I have 4 declarations A, B, C and D, where A is integer, B is real, C is an array data type of integer and D is called as a pointer, integer pointer. Now, we actually apply this productions rules here. P tends to D, then D tends to D colon D. Now this D can be abbreviated as ID colon T. So T is integer. Now this D can be abbreviated as ID colon T. This is B colon real. and this D can be once again abbreviated as D comma D, because D has to be declarations. There are 4 declarations, so declaration has to be extended here. So there should be 4 D's here so that it can accommodate all the declarations here. Now the third one is D is ID tends to D. Now this is a array data type, so T tends to array. Array is open brackets, then 10, then close brackets of integer. Everything has to be mentioned here. And the last one, D, should be ID tends to D, where D is actually ID is tends to D and T tends to a pointer variable. Now we will closely introspect how to actually make an entry, corresponding entry in the symbol table for all these declarations. Now the first type, we will evaluate this. When we evaluate this, this ID is actually A and the data type is called as integer. So when there is a declaration, first we have to make an entry of a symbol table of the corresponding ID. The corresponding ID name is A and its corresponding type is called as integer, and the offset, initial offset, is 0. So we have to make an entry like this. So here the corresponding width of it is 4, because since it is an integer, it is 4 and the type is integer. Now we have to make an entry in symbol table. So A is called as a data variable and data type is integer, then offset is initially 0. Now we will come for the next one. The next one is here. So this is called as ID tends to be real. So ID is a B and data type is called as real. Now obviously integer data type capacity is actually 4, width is 4. Now the next offset should be 4 here. 0 plus 4 should be 4. Now we will make ID dot name is B and ID dot type is real. So we will make here. So ID dot type is real and the width is actually 8 here. So now what happened here is, initially you have 4 data type, size of integer is 4. So 0 plus 4, that's why it is 4 for real data type, because real will be stored in this memory location called as 4. Now we will go for the third one. So this is an array data type. When you store an array data type, so it is an integer size. Now the width should be 40 here, because there are 10 memory locations for integer here, and width of one integer is 4. So 10 into 4 should be 40. So T dot width should be 40 here, and the type of an array is integer. So here this will be made as T dot width is equal to 40 and T dot type is integer. So that will be made an entry in the symbol table. So array of 10 is called as number and the type is integer. So now what happens here is, offset is 12. Why? Because the initial offset for B is 4. Now the data type, the width of B is actually 8. Okay. So 4 plus 8, 12. So 12 will be the starting address location for C. Now we'll go for the last one, pointer variable. So we have to evaluate this portion, pointer variable. Now ID dot name is D and pointer variable has a data type width of 4 here. So width is 4 and type is actually integer. So what happens here is, initially it is 40 for array. So 40 plus 12 will be added as 52. So the starting location where the memory location for D will be stored here is 52. So that's why. Okay. So this is how we can evaluate declarations using the semantic rules. So thanks for watching the video. Have a good day.